Hello, welcome everybody. This is the session where we're going to do a deep dive into using Apex for building your agents and apps. First, a quick forward-looking statement. Salesforce is a publicly traded company. Please make your purchasing decisions based on products and services that are currently available. Thank you for being here today. We're really looking forward to sharing these best practices with you so you can take them back to work and then start implementing them where needed. I am Daniel Bellinger, the product manager for Apex.
Hey folks, my name is Mitch Spano. I'm the product manager for the Salesforce CLI and the IDE extensions and the DXMCP server. But in a past life, I was also Daniel's peer as a PM for Apex.
I'm Peter Churchill, a Salesforce MVP and a developer in this ecosystem for 20 years.
Ooh, right. So today we're going to run you through 6 key areas. Key considerations for what you need to do for your Apex to keep it secure. Considerations you should need when your Apex is working and providing functionality to an agent. Considerations when you're working with creating your classes and how they are versioned and how that should evolve over time. Peter's going to run us through some framework considerations when implementing and choosing frameworks. We'll run through asynchronous patterns to consider to make sure your code can scale correctly. And finally, we'll do a quick spin through a number of anti-patterns we've seen out in the wild. So first, let's talk about security. Hopefully, most of you know when you implement DML or SOCL in Apex, you should make a consideration. Should this code run in user mode or should it run in system mode? Your default choice in just about any scenario should be user mode, and it's best if you're explicit to say with user mode or as user in those operations. That will cause your code to run with the behavior of the current operating user or the current running user. That's by far the best decision you can make. If you need to explicitly escalate the level of access that transaction have, you can switch to system mode, but do be explicit in that change. As part of that consideration, you should remember in version 67, we're actually changing the default if you omit that statement. It's going to change from always acting as system mode if you omit it to always acting as user mode. But it's generally much easier if you're explicit in all your decisions. Another part of that change that's coming in version 67 is we're fully deprecating the with security enforced statement at that API version, but you can switch to with user mode in its place. I actually recommend that you go back through any older class that might still be using with security enforced and also make that change there to use user mode. The other side of the coin for enforcing security in Apex is the sharing declaration. Again, the best practice is here to be explicit and use with sharing to enforce the user's level of record level access. That's by far the easiest consideration to make or the easiest, safest option to use. But if you need to access records that the user might not otherwise have access to, you can use without sharing. In very specialized situations where you need your code to be able to adapt to the calling class, you can use inherited sharing. Inherited sharing has the benefit that if somehow that class becomes the entry to the transaction, it will default to with sharing enforced. So a much safer option. Now, there is the fourth option, which is you completely omit the sharing declaration. We don't recommend this if your class can ultimately do SOCL or SOSL or DML, because it can lead to a rather, it's not ambiguous, but it's hard to reason about scenario of which mode it's actually going to end up in operating in. So I recommend that you use one of those other 3 options. Something to bear in mind though, is if you are doing user mode operations, they will actually override all but with sharing. They all operate as if it was with sharing explicitly. One other area to consider when enforcing security in your Apex code is how do you handle user input? So say the user has provided you a string that you're going to run against a SOCL query. The worst possible scenario, so this is what you should not do, is take that string and directly concatenate it into a dynamic SOCL query to execute. Because if the user is aware of what they're doing or they start testing how your code responds, they may discover that they can inject a particular set of strings, a particular string with single quotes in it, which will cause your SOCL query to behave in unexpected ways. So here, rather than deleting the context that you expected it to do with just the specific name, it will actually reach out and potentially delete all the contacts in your org. So definitely not a practice to do. Don't directly inject user input into dynamic SOQL queries. Now, we provide mechanisms that mean you don't need to do this in Apex. The recommended approach is use a binding syntax directly. There's a nice new query with binds, or relatively new query with binds available to you, which will take a map of bind parameters, and that will ensure that those don't bring in injection attacks into your code. You do have a third option. If you absolutely needed to, you could use escape single quotes, but query with binds is by and far the best option to ensure that that doesn't happen to your code base. Now, you have all this code, you have all your security enforced, and that's excellent, but it's very important that you also write test cases for your code. Now, one thing to consider when writing your test cases is how do you test those boundary conditions of whether the user does or does not have access to expected objects or fields. A really nice mechanism you can use to test this is the minimum access Salesforce profile. With this built-in profile, in your test cases, you can create a permission set and assign it to a dynamic user that you create in the test case, and that then allows you to run those tests with this minimum access user. And because that user has essentially access to nothing, you can instead build up in your test case explicit object and field level permissions to grant to that user. So when you do a system run as, you know it only has that specific level of access. And that allows you to test a number of boundary conditions in your test classes. You might, something to bear in mind is when you do write these tests, if you have a particularly old org, that profile might be missing. So make sure you reach out to support if that is the case. They can enable it for your org. And then one other aspect when looking at the security model in your code base is obviously finding these things that might be historic you might have missed. Static code analysis through the Salesforce Code Analyzer is an excellent way to scan through your code base to look for those scenarios you might have missed. Code Analyzer is available for free in a number of places that you might want to run it, such as directly in the CLI, in the IDE, or you can embed it into your CI/CD pipeline to ensure it's checking everything as it comes into your project. As an example of what it might look like, if you were to run it in the IDE, say against a DML statement, it will flag that line in the class and tell you, like, hey, did you consider that this should probably be operating with user mode, or you need to explicitly check the object and field level security for this operation before you do it. And then if you needed to escalate, you could use with system mode, and it would be clear what your intent was. Right. Best practices for Agentforce. Mitch, can you run us through that, please?
Excellent. All right, folks. So Agentforce is changing the way that business is done on the Salesforce platform. And you all have a tremendous amount of investment in your existing Apex code. And it's great because you can expose Apex actions to be invoked by your agent. But there are a few things to keep in mind when it comes to writing Apex that is to be invoked by an agent. So first thing is that there are two different types of agents on the Salesforce platform. There is the employee agent, which is relatively easy to reason about. This just runs in the context of the running user who is behind the keyboard interfacing with the agent. That's pretty straightforward. The one that you need to really make sure that you're being explicit and careful about is the Agentforce service agent. This runs as a designated user that is created, that is assigned at the time that you create the agent. So if you've ever written Apex that is to be exposed to an unauthenticated guest user on a digital experience site, this is very analogous to that. So all of the things that you would need to take into consideration there are applicable here. One thing to note here, I think I've got a little laser. Oh, no. Maybe I don't have a laser on this pointer. There is in Agent Builder, there is a variable called verified contact ID. So Agentforce can go ahead and send a one-time passcode to somebody to make sure that they can verify their identity, and that will give you the ID of the contact that has that phone number or that email address. So then if somebody says, hey, help me to cancel my order, you can make sure that you only query for orders that are related to the person with that verified contact ID. So make sure that you are being very careful about the rows that you select and that the field that you include within the response when you're running things within the context of an Agentforce service agent. And as always, like Daniel had mentioned, you make sure that you always are very explicit about user mode or system mode and be very careful when you choose to escalate your privileges. All right, a few other things to keep in mind here. The Agentforce, the Apex that you expose to Agentforce is typically exposed to Agentforce via invocable methods with invocable variables. Historically, these have been used in Flow, and they have this really great property of them that they include a description, a label and a description. When you're within Agentforce and you choose this invocable Apex method, the labels and the descriptions were going to be automatically defined as the default values for the instruction for the agent. And this is super helpful because this is what's going to help the agent to choose this particular method and to populate its variables appropriately to facilitate the request with the customer. So always make sure that you are populating the description and make sure that it is useful not only for people that are reading your code if they were to be using it within Flow Builder, but also for agents who might be invoking your code as they're helping a customer of yours out with a request. All right. The final thing to keep in mind when you're writing Apex that is intended to be invoked by an agent is that there's a little bit of nuance with error handling. If I historically was writing an Aura-enabled method, for example, for a Lightning Web Component, and I threw some exception, a new Aura-handled exception with a nicely formatted error message that would render to the user, and they say, hey, that order does not exist. However, regardless of how well formatted your error message is, any exception that gets thrown when Apex is invoked by an agent will result in a generic error message within the chat that the person is having with the agent. So it's up to you to create an error and have that be a typed response value to the agent and include that error message. Hey, we were unable to identify an order with that order number or whatever runtime issue you may have encountered. But that also means it's up to you to roll back anything that you may have done throughout the scope of that invocable action. So use database.set save point to create a save point, collect your errors, return them in a response object, but before you do the return, make sure that you roll back if you have an error. This will help you to make sure that your conversations with your agents that your customers are having feel natural, and you can carry on, and everything will feel very smooth. So these are some tips and tricks for writing Apex to be consumed by agents in Agentforce. All right, switching it back to Daniel.
All right, thanks, Mitch. So API versioning and how that affects your classes and triggers. Whenever you create a new Apex class or an Apex trigger, it takes on the current highest API version that existed at that time. So in this case, it was created in API version 35, and that gets baked into the metadata about that Apex class. Now that's really important because it ensures that over time, as the API version goes up and we make changes, that class remains consistent, so any breaking changes don't automatically affect that class. But it is important that you actually come around and revise that class from time to time and bring that API version up. As a form of best guidance for maintaining your API versions in your class, you should strive to keep to a minimum number of API versions. So like obviously one is best, but like you can keep that minimum, will make your life a lot easier. And when you are choosing an API version, aim as high as possible, so closest to the most current release is best. Now, obviously, bearing in mind that there is a release window where your scratch orgs and your sandboxes may be on an API version that precedes your production org, but once that production org's reached that API version, you should ideally be aiming for that. And then overall, aim to keep all those Apex classes and triggers within an API version that's been released in the last 3 years or 9 API versions. You'll get a number of benefits from this. You'll get our security fixes, our performance fixes, and it'll also help with the general consistency of how your code runs. As an example of why this is important, here is an API version change that came out in version 61. So historically, if you had a base class with a global method and a private method, that's pretty normal, and maybe you had somebody extend that base class, again, all pretty normal, and then something invokes that instance of that subclass and the global method on it. So the normal execution flow does exactly what you expect. It calls the global method calls the private method. Again, nothing surprising here. This should all be pretty standard. Now, the problem arose if the subclass implemented its own version of the private method with the same name as that in the base class. Now note that there's no extends or overrides here. It's got its own independent private method. Now the problem is, before API version 61, it would actually call that private method. Now depending on what that private method was doing, that could actually have some rather adverse side effects. we couldn't directly version that out, or we couldn't directly change that for all of your code bases because you may have inadvertently been depending on it. So we deployed it as an API version change. But that's the sort of thing that we need you to pick up. By upgrading your API versions, you automatically get fixes like that you might not have been aware of. You might not even be aware that that exists in your code base. But by maintaining that consistent API version, you can ensure that your code gets all those best fixes over time. But you can also test it in a managed fashion as you have control of when that API version gets upgraded. Right, and with that, Peter, I think I'll pass it. Can you run us through some framework considerations, please?
Thank you, Daniel. So I just want to go through some thoughts around utilizing frameworks, choosing frameworks. I know a lot of people have very passionate views on frameworks. I've been on LinkedIn and seen the discussions. So I don't want to necessarily recommend specific ones so much as what do you need to think about when you're choosing them. So why do we want a framework? Because we need our code to be consistent. We need it to be flexible so we can use some of these frameworks to inject at runtime from metadata. We need to write clean and reusable code. And that's especially true in the age of AI. When you're looking at that code and AI is learning from your code base, you want it to replicate something that's good code, clean code, reusable code. And using libraries, we can get a lot more functionality, such as dependency injection. We can mock with testing and DML. And we can make sure that when principles like don't repeat yourself are done for us without us having to build up a whole sort of library of code to do that. So when you think about a framework, there are lots of them out there. I think fflib is probably the best known of the frameworks, but there are lots of libraries coming through recently. But when you're choosing it, make sure it's active. Like fflib has people owning it. I think people like Beyond the Cloud run the SOQL library. So make sure they're active. But to everything we've heard today, even more importantly, is it maintained? Are they using this new security updates? Are they updating their API versions? Do they use like SOQL with bindings with user mode? Right? And then if they are doing that, how easily can you update it? Is it like, do you have to copy and paste the code in? Or can you take it from a managed package or an unlocked package? Think about those, making sure that you are updating as they are updating. Otherwise, you lose a lot of that benefit. And then also just like what is important to you? I mean, you want a framework that enforces consistency. Will your team be able to do that? And that, I think, is not always the case, right? Because you need ease of adoption. And the reason I say that is because as someone who's done this for 20 years, I've logged into a lot of orgs where I see abandoned frameworks, abandoned libraries. And that's the worst of all worlds, right? So I know everyone wants to become like, and use the full framework. When it's done, it's very powerful, but make sure you can do it, right? How complex will your code base be? How big or experienced is the team? And then almost how much turnover? Is it going to be a team that you're going to onboard and be able to get them up to speed on something like fflib? Or is this something you're going to hand off, give to somebody else? And in which case, a reason we sort of look at a continuum, right? So maybe for fflib, some people have huge success with it. Great. Some of you say, there's no way our team can take that on. But that doesn't mean you can't use some parts of the framework. So behind me, Mitch has written the great trigger frameworks. And all of those things, they're a lower barrier to entry, but they bring huge benefit. Probably the #1 architectural flaw is multiple triggers on an object. And a trigger framework like that can bring dependencies, it can bring metadata support, it can bring flexibility. And if that also consider that if you have something like MPSP, I do a lot of work in the nonprofit space. A lot of packages have a trigger framework built in, and they also deliver huge benefit. And I say, if you're using some of these, you kind of need to use it. Because I've seen orgs where the performance is terrible, you implement their trigger framework, the performance issues go away. So start off with that. I think there's no reason you wouldn't use a trigger framework, honestly. I think you're asking for trouble if you don't. But then having done that, you can then provide some of the things we're talking about around consistency, where you want things like mocks and SOQL testing. But there are lots of great libraries out there. I know Beyond the Cloud has the SOQL library and the DML library. There's the Nebula logger. And I've seen great success with those, where I've seen tremendous performance improvements by implementing that. But by doing those things, there's a lower barrier to entry, but you get immediate benefits. I mean, I think the SOQL library is 2,500 lines of code. I'm not going to write that, but I can immediately start using it. It's easy to bring people up to speed on it, and then they can deliver the benefits of having consistent code that I, as a developer or as a reviewer, but also if AI is writing it, I can say, use these libraries, and I can review the code a lot more seamlessly. So just sort of as an overview of how we see it, I say fflib is the well-known framework. It has all of those pieces. But then also consider just like the trigger action framework, some of these libraries, the Nebula logger, and all of those pieces. And you can get that adoption a lot more quickly, get the consistency in the reusable code you want, and see significant benefit without necessarily having to go through a full action of implementing something like fflib. Thank you.
All right, thank you very much. Switching gears here, I want to talk to you all about something that is very powerful on the Salesforce platform, and that is asynchronous Apex. But as the movie line says, with great power comes great responsibility. So I want to give you all some insight into some things that you should be thinking about whenever you consider going asynchronous with your Apex. First thing is that asynchronous execution is very powerful, but you're going to need to make some upfront choices about if it's the right call, how are you going to handle some of these things. The easiest thing to think about is that like asynchronous Apex, there's not necessarily somebody in front of the computer, in front of the keyboard, making sure that an error message would be handled appropriately. So if you go asynchronous, you're going to need to think about how am I going to handle errors? Am I going to retry? How many times am I going to retry? What happens when I exhaust my retries? Another thing to consider is that you might be considering going asynchronous because you have encountered some heap limits or you need some greater CPU time. And that's great because asynchronous Apex affords you greater of those transactional limits. However, asynchronous Apex also has its own consumption event because it has a daily allocation of asynchronous jobs that can be run on the platform. It's 250,000 plus some linear multiplier of your user license count. So every time that you invoke an asynchronous job, you're decrementing something from your daily allocation. Another thing to consider is that these asynchronous jobs are not guaranteed to be instant. They're not guaranteed to be ordered. So this can result in some concurrency and locking issues that you need to make sure that you're upfront about and plan accordingly before you start writing the code. So some tips for success here when it comes to writing asynchronous Apex. The first one is probably the most trivial one. Just perform the compute synchronously. If you can, whenever you can, do it synchronously. You're going to have synchronous error handling. You don't need to worry about retries. If you really need to go asynchronously, though, however, we recommend using queuables. So there are some legacy asynchronous mechanisms, such as the @future annotation. Queuables have a tremendous amount of investment from the Apex team over the recent years, and they just provide better developer ergonomics. They perform better. There's a lot of things that you can do, like you could set a maximum stack recursion depth prevention. And with the advent of Apex cursors, now you can use queuables to page through large record sets, something you would have otherwise needed to rely on batchable for. So if you ever need to go asynchronous, queuable should be the first thing in your mind when it comes to mechanisms to consider. Another thing that you want to keep in mind here is that sometimes your asynchronous logic needs to be triggered based off of some DML operation. And this is a little bit of a risky pattern. You need to make sure that you're very careful about how you do this. The well-architected guide for record-triggered logic on the Salesforce platform contains this diagram that you see right here in front of you. So we'll quickly go over it, but I just encourage you all to take a look at the well-architected guide because this will go into much further depth. However, the main question that you need to ask yourself is it possible to have a very large quantity of DML operations on the given S object? And if so, for example, maybe you have a calendar synchronization. Maybe you're synchronizing Outlook calendars to Salesforce events. The first time you run that, you're going to have a large volume of these operations. And if you're triggering an asynchronous job, you could really easily consume your asynchronous allocation for the day. So if it's possible to have a very large daily job allocation, if you can, try to use change data capture on that S object. If you have change data capture and an change data capture trigger written in Apex, then you can handle all of the volume that you need to. There are some considerations. You don't get the old values, but it's a very effective mechanism to handle high scale. That's exactly what it's built for. If you can't use change data capture, consider doing a scheduled job. Hey, maybe every 15 minutes, we're going to process the things that have changed within the last 15 minutes. But if you do need something that, hey, I need to go asynchronous based off of this, and it's a lower transactional volume, the main question you need to ask yourself is, do you need a custom retry logic? The default mechanism that you should be considering is a record-triggered flow. A record-triggered flow with an asynchronous path has an automatic retry mechanism. It will retry up to, I believe, 4 times for you on your behalf. So you don't need to worry so much, and you don't need to architect your retry mechanisms. But if you do need custom retry mechanisms, maybe you want to retry 8 times, and if you exhaust those 8 times, then you'll fire an alert to the on-call engineer. Then you should consider a triggered, have an Apex trigger or a record-triggered flow that invokes a queuable. Now, however, I just say with caution on this because, again, you're one large DML event away from exhausting your asynchronous allocation. So make sure you're very careful about how you do this. Again, return to the record-triggered automation guide for more guidance. All right, we're going to switch gears here a little bit and talk about some anti-patterns, some things that we commonly see that are technical debt and can cause you headaches down the line. And we're going to keep on the topic of asynchronous Apex, right? So the first and kind of most trivial example of something to watch out for with asynchronous Apex is using an incredibly small batch size. This is kind of a trivial thing, but if you're using batch size 5 and you're chunking through hundreds of thousands of records, you're going to burn down your daily asynchronous job limit pretty rapidly. Another thing here is as we kind of discussed earlier, there's no guarantee about ordering or mutual exclusivity of asynchronous jobs. So sometimes you might say, hey, I want a scheduled job that will reschedule itself to make sure there's only one operating at a time, and you'll guarantee mutual exclusivity over the records you're trying to process. This is a little bit more of an advanced pattern, but the problem becomes if you try to, the job will self-terminate and then reschedule itself. This can be really problematic, especially in like a scratch org, if there's nothing to process. Because then you could be spinning up a scheduled job every single minute and it does absolutely nothing, again, burning through your daily allocation of asynchronous jobs. The next one here is pretty interesting. So you're using a queuable, you're implementing the finalizer interface as well, you're using a database cursor, you're paging through, you're trying to do all of the things right. You set a maximum stack depth and you enqueue the job. However, if you look in the finalizer context execute method here, that's where we're re-enqueuing the next chunk. This is a little bit of a nuance here, but if you do it this way, you're actually breaking out of the maximum stack depth prevention. So if you use a queuable and you need to queue the next chain of the job, do your enqueuing inside of the queuable context execute method, not within the finalizer context execute method, because you will break out of maximum stack depth recursion prevention. And then finally, on asynchronous Apex patterns that become problematic here is something like this, where you have a queuable and a future, and they keep calling each other back and forth. This can rapidly burn down your asynchronous Apex consumption. And again, you're circumventing all of the maximum stack depth prevention things that queuable has for you. Generally speaking, we do not recommend doing something like this. So these are some of the asynchronous patterns that we consider anti-patterns. I'm going to switch it over to Daniel now for the rest.
Great, thanks, Mitch. Oh, was that? Oh, yes, right. So this particular slide is not an anti-pattern. So I have a test controller, and I want to deploy it to my production org. So I do the right thing. I write a test class, and I check how does it handle 10 contacts. And I fire that test off, and I deploy it to production, and I get 50% coverage. That's pretty good. That's a good start. And so then I come back to my test classes and think, well, what am I missing? I'm missing the edge cases. I'm missing the boundaries. What happens if I pass it null? What happens if I pass it the empty string? What happens if there's no records to be found? So I start testing, what happens if I test my security model in various ways with various levels of user access? So I test all those permutations, and I get my code coverage up to 79%. So between that and ensuring I had at least one line of code for all, one line of coverage for all the triggers in the payload, I can deploy that to production, and that's great. Now, that's not an anti-pattern, so what does an anti-pattern in testing look like? Well, it can actually be quite shocking, so you might want to cover your eyes because this is quite gruesome. These are things we've roughly seen in the wild, lots of assignments, lots of calling methods that perhaps don't need to be called that many times. Again, more assignments. This goes on for a while. Really odd loop statements that seem meaningless. People who like lorem ipsum. Now, okay, this one is particularly shocking. Can anybody spot what's wrong here? Where they put their code coverage hack? It's a bit of a rhetorical question. It's in the finally block. What's going to happen every time the main code path runs? It's also going to run that anti-pattern. And I've also seen this in constructors, so that's particularly problematic in the way they've applied that. Not trusting our Boolean logic. Okay, I think you get the idea, but generally, it's a repeating lines of code that no normal developer would write for a normal business solving situation. They're manipulating our code coverage results. And as an analogy, it's a bit like you went to the fuse box in a car or in your house, took all the fuses out and replaced them with bolts. Those tests are going to run 100%, they're always going to pass. But that's kind of skipping over the very important fact of why they're there. They're actually there to prevent severe problems downstream, say in your production org, when this code reaches it and deletes something it wasn't supposed to. It's a protection mechanism for you to ensure your production orgs are well looked after. So again, these code coverage anti-patterns, they can hide significant issues that could otherwise reach your production org. As we saw, sometimes if they're really poorly implemented, they'll impact your business performance logic if you put them in your constructors or finally blocks or somewhere else odd in your code. They also have a secondary side effect that they cause excessive code character usage, which is usually where it first manifests into the org. Somebody will realize they've run out of code characters, and then there'll be an examination of their org, and they'll realize 50% of it is filled with I++. And then that sort of leads to the next part. It's created a significant amount of technical debt for someone, either the developer who created it or some other poor developer who's now inherited this large shortage of test coverage that they're going to need to address to move their org forward. So it's sort of a general statement. Obviously, be on the lookout for these things. They will need to be addressed in orgs. It is a bit of an overhead, but the ultimate end goal of having that high level of coverage of tests is ultimately better for your org. So with that, we'll provide the slides for this session and this QR code.